Hi, I'm Laszlo from DirectFEM, and in this video, I'm going to show you how to compute mechanical stresses and displacements on a broken CAD geometry like this quadcopter model that you see on my screen right now. As you can see, this is a really non-water type geometry where there are no triangles matching the other one. Some of them are even intersecting, and we have a geometry which is full of non-manifold features. This is something that a normal mesh generator wouldn't like at all. So let's go to our website and let's log in. So I'm just going to enter my credentials. And once we are logged in, we are greeted with this screen with a summary of our simulations. So I'm just going to add a new one here. It is going to be called quadcopter. And in order to simulate the quadcopter, of course, we need to upload the STL file that represents its geometry. And because what we want to do is we want to simulate how the quadcopter deforms under its self-weight while these four surfaces are being fixed. We also need to upload the STL file of those four surfaces. So let's do so. And once these surfaces are uploaded, we are ready to set up the simulation. So first, I'm just going to set the main model as the main geometry of our computation. I'm going to leave the material parameters at their default values. I'm going to set 32 by 32 by 32 elements as the discretization parameters. And in order to apply gravity, I'm going to set the gravity vector to 0, 0, -1, meaning that the gravity is acting in the vertical direction on this 3D view. Once we are done with setting up the material parameters, we can set up the post-processing. Once the computation is done, we want to visualize the results on the main model, and we want to see displacements and form mesostresses. Before we are ready to submit the simulation, we need to set up, of course, the boundary conditions. So let's do so. First, we add a boundary condition specifying that these four surfaces are not allowed to move in the X direction. Similarly, they are not allowed to move in the Y direction, and they are not allowed to move in the Z direction as well. Once we are done with setting up the boundary conditions, we can click on Save and submit the simulation. Your simulation is now submitted to a remote computer, and you will see that after a couple of seconds, its status will change from submitted to computing. Now you will have to wait a couple of seconds, about 10-15 seconds, and after this time you will see that the status changes from computing to finished. Once the computation is finished, we can click on the name of the simulation again to visualize the results. Here we need to wait again a couple of seconds until we download the results from the server. And once the results are downloaded, we can just visualize them in the browser directly. So for example, the displacements will look like this. There is no displacement at the four locations where we specify that there should be 0 displacement boundary condition. And of course, the maximum displacement occurs in the middle. And we can also have a look at the stresses where we see where the peak stresses will occur under these conditions. And if you want to perform a more advanced visualization of the results, we can download a zip file with the VTUs that can be opened in ParaView. Once the zip file is downloaded, we just simply extract it and can go to ParaView. And open, for example, the file representing the stresses. And have a look on the stress field directly. Thanks a lot for watching this video. If you are interested in trying out ReveaL on your own, just go to our website and request a trial license. Bye-bye.